In this section, we want to talk about computer engineering and have a brief overview of this field. As we mentioned in a previous section, some of knowledge developed in theoretical computer science is used in this field for building hardware and computer applications. The field of computer engineering is usually divided into the two parts, hardware and software. Let's start with the hardware and briefly review some of its details. In this section, the discussion is about the fact that we have a mathematical model of computation and computers. The question is how we can build and realize this model. To do that, we needed an architecture for building computers, which is where the field of computers architectures comes into play. In 1945, John von Neumann proposed an architecture that is still used today in the construction of the modern computers. This architecture is based on the idea that we have a Turing machine. The state machine and Turing machine effectively plays the role of the CPU, and the tape plays the role of the memory. There is also two-way connection between the CPU and memory, allowing the CPU to read from and write to memory. Now, let's take a more detailed look at the CPU. In the CPU, we need a unit that performs computations, which is called the ALU, Arithmetic Logic Unit. This unit is responsible for performing arithmetic operations and logical comparisons. In addition, we have a control unit, whose job is to tell the ALU which operation it should perform at any given time. We also have a set of registers, whose role is to provide temporary storage of information. Together, these components form the architecture that we need. In practice, a computer also requires input and output, so the hardware devices must exist alongside it, such as a keyboard, mouse, and monitor. If remote communication is required, we need a network card. If graphical processing is needed, we use graphics card, along with other components as required. To enable communication between these hardware components, we need a path or a bus, to which the hardware devices can connect in order to send and receive data. This was a very simple introduction to modern computer architecture. Another important part of the computer engineering is related to the software and programming languages. In this part, now that we have a CPU, we need to tell it what to do or which computation to perform. The instruction that the CPU can execute must be expressed in a language, which is the machine language, also known as the zeros and ones language. Now, why 0 or 1? Because engineers realize that if we have a wire, we can consider low voltage as a 0 and high voltage as a 1. Using these low and high voltage levels, it becomes possible to control everything on the CPU. But writing instructions with the zeros and 1 in a way that CPU can execute them is very difficult. For this reason, the assembly language was invented, which made the work somewhat easier. This was done by assigning symbols to a certain sequence of the zeros and 1, and working with these symbols was easier. However, its drawback was that for someone writing a program, it was difficult because they had to know all of the details of the CPU they were programming for. And this made the process of writing programs lengthy. For this reason, higher level programming languages were invented. Their advantage was that these programming languages were closer to the conversational language we speak, and we wrote the instructions that the CPU was supposed to execute in a more human-like and conversational form. Now, these instructions written in a programming language had to be converted into zeros and ones, This requires the instruction to be translated, and this translator is called a compiler. And then the development of programming languages and compilers eventually led to something called an operating system. An operating system is a very large program that manages and controls all hardware's resources, such as the CPU, memory, input and output devices, and more. In the end user interacts with the computer through the operating system to perform the tasks they want to do. As we moved forward, engineers realized that sometimes they needed to work with a very large amounts of data and store them, which led to creation databases. Databases were programs that organize and store data, and if you want to access a part of data, we had to write a query. How data should be organized and stored, and how the execution speed of queries can be improved or optimized are topics that are discussed within the field of databases. In addition, if I'm going to write a very large program, I need to be able to involve other people in developing it. Defining each person's responsibilities, as well as how the software is maintained and supported, are topics discussed in the field of software engineering. Moreover, if I have a very large computation, I should be able to use multiple computers to perform it. Topics such as how these computers communicate with each other and how the computations is distributed across the network of computers give rise to an area known as a distributed and parallel system. There are also many other topics that will fall under the umbrella of computer engineering. Now that we have been able to build practical tools, we should use these tools to create applications that can be used in everyday life. People who work with these applications no longer necessarily need to have computer knowledge. This field is divided into many different areas, and here I will mention just a few of them. Artificial intelligence, or AI. In this field, we discussed how we can make computer intelligent. In addition, within the field of artificial intelligence, there are many subfields. For example, machine learning, which includes methods where we train a computer model on how to perform tasks. There are various types and approaches to learn. Another area is natural language processing, NLP, which includes methods that allow us to communicate with the computers using natural conversational language, so the computers can understand our language and execute our commands. The next field is computational neuroscience. We're inspired by intelligence of living organisms. We can design and implement models based on which computers can operate in a more intelligent way. In addition to this, we have other categories under the umbrella of computer applications. Computer vision, which discuss how computer can see and understand in a way similar to humans. The next one, we have image processing, which involves techniques used for processing images, such as software like Photoshop. We also have human-computer interaction, which focuses on how an application interacts with the user in this field. For example, it discusses how the user interface or GUI should be designed. Game development is another area that deals with how games are created or how games engines are built. Big data involves how to analyze and process large data sets and extract meaningful insight from them, and many other fields.